Lisa Friedrich. I'm recording for my biology class. We're going to be talking about hydrophilic and hydrophobic. So let me go ahead and get started. The first question that we needed to address was, what does the term hydrophilic mean? So hydrophilic is a material that has a special affinity for water. So that could be anything that basically when it contacts a surface, it'll spread, and it'll maximize contact with that surface. So an example that you can use is like watercolor paper. So if you dip your paintbrush in water and you put it onto the watercolor paper, you'll notice as the water drips off the paintbrush and drips into the paper absorbs it and it spreads throughout the paper. So that is what would be hydrophilic. Now, if we talk about hydrophobic, that's the opposite of hydrophilic. So it means that it is a type of material that does not work with water. So it's, what's the word I'm looking for? It deflects against water. So think of things like a raincoat, like the material a raincoat's made out of, or anything that's like considered waterproof, like a waterproof phone case. Now, what exactly does that mean? So that the generic gist that I have is that a surface that has a contact angle that is less than 90 degrees, okay, that would consider itself to be a hydrophilic surface, okay? And any surface that is hydrophobic would be something that is greater than 90 degrees. Something that we can look at is why certain substances are hydrophilic. So one of the biggest things that I've read about is the shape of the surface is what kind of constitutes it being hydrophilic or being hydrophobic. So what you can do is you can add nanopatterns to the surface of something to make it either more hydrophilic or more hydrophobic. So basically that's just changing the outside of the item to make it a certain way. So the shape of the surface and the surface properties are what really pushes it to be a hydrophobic or a hydrophilic surface. So one of the examples that I found too that was really interesting was that of the Stenocara beetle. It's in the African Namib Desert. So one thing that it does is combines both traits of being both hydrophilic and hydrophobic. So it has these little bumps, hydrophilic bumps on its back and on its wings. And it encourages condensation from the fog around the desert. And then it has these hydrophobic troughs that are surrounding it, which helps gather the beads from the hydrophilic bumps, and it directs it into the beetle's mouth. So it's kind of fascinating how that works as a system together. So the last thing that we're talking about is what it means when a substance is placed into a beaker of water. So when you put a substance into a beaker of water, if you're looking for something that is hydrophilic, so again, I'll use watercolor paper. If you dip paper into a beaker of water, it's obviously going to absorb the water and disintegrate. So that would make it a hydrophilic material. Now, on the other side of things, say you put in a laminated ID card, okay? So the surface of a laminated ID card is going to be really slick, and it's not going to absorb very well. So that's something that would be called hydrophobic. So if you put that into a beaker of water and you take it out of the water, you'll notice that the droplets are going to run off of it instead of absorb into it. And I hope all that made sense. Thanks.